Welcome to Metrology lecture series. In the present video, we will discuss the gauges and its design. First, we will look for what is the gauges. Gauges are the scaleless inspection tools, which means gauges are not having any scale to measure the dimension of a part. So gauges are the rigid tools. Gauges are used to check the dimensions of a manufactured part. So with the help of the gauges, we will check the dimensions of a manufactured part and not measuring the actual dimensions of the part. So with the help of the gauges, we do not measure the actual size. So gauges are used to only determine whether the manufactured part has been made within the specified limit. So gauges are not measure the actual size. Just it will be check the manufactured part is made within the specified limits or not. So gauges are consisting of the two sizes corresponding to their maximum and minimum limits. So gauges are having the two sizes. So one is to check the minimum limit of the size. Another one is to check the maximum limit of the part. So gauges are consisting of two sizes. One is to check the minimum limit of the part. Another one is have to check the maximum limit of the part. So gauges whole limits we are calling as the plug gauges, and similarly gauging for the shaft we are calling as the snap or ring gauges. So gauges are used to check the whole limits, that is we are calling as the plug gauges. Similarly gauges are used to check the limits of the shaft, that is we are calling as the snap gauges or the ring gauges. Next we will discuss the advantages of the gauges compared with the other measuring tools. So gauges are easy to employ and gauges are used by unskilled operators. So for the using of the gauges, no need of the skilled operators. And gauges not necessary to make any calculations or to determine the actual dimensions of the part. So with the help of the gauges, we will check the dimensions of the part whether it is in the specified limits or not. So we are not measuring the actual dimensions. So no need of the calculations. Time involved for checking or inspection is considerably reduced. So with the help of the gauges, so time involving is very less because it is just checking the limits, not any calculations. So gauges are having the wide applications in engineering, practically for the mass production. Especially gauges are used for the mass production. So next we have to discuss the gauges differ from measuring instrument. So first one is for the gauges there is no adjustment is required in their use because it is a rigid tool. And second one is gauges are not general purpose instrument but are specially made for some particular component which is to be produced in sufficiently large quantities. Previously we discussed gauges are suitable for the mass production. So in the mass production we are producing the similar component and especially for the suitable dimensions only we will be used. So next third one is gauges are quick results about the conformance or non-conformance of the part with the specified tolerance. Next we will discuss the need of the gauges. Manufactured parts must be checked to determine whether they are according to the specifications or not. So we know that. So while the manufacturing process, we should have to check the dimensions of the manufactured part. The size of a component can be checked using different precision measuring tools. These tools shows the actual size of the part. Then this measured size is compared with the standard size to decide if the part is acceptable or not. So this is the general procedure of the measuring dimensions of a part. So first you have to determine the actual dimensions of the manufactured part. Then these dimensions are compared with the standard dimensions of the part. Based on these variations, we should have to take the decision this manufactured part is acceptable or not. But in mass production, many identical parts are made. Measuring the exact size of every single part takes too much time and involving too much of the cost. So instead of measuring each part, we are using the gauges. So these gauges quickly check whether the part is within the allowed tolerance limits. So gauges are especially using the mass production. So instead of measuring all the identical part, we are check the dimensions whether the manufactured part is within the tolerance limits or not. Next we will discuss the limit gauges. As there are two permissible limits of the dimension of a part, high and low. So two gauges are needed to check each dimension of the part. One is corresponding to the low limit of the size and other is the high limit of the size of that dimension. So these are known as the go and no go gauges. So we know that there are the two permissible limits of the part. One is the lower limit, another one is the upper limit. In this regard, we need the two gauges to check the upper limit as well as the lower limit. So one gauge is required for to check the lower limit of the part. Another gauge is required for to check the upper limit of the part. So these gauges checking the lower limit and upper limit of the parts we are calling as the go gauge and the no go gauges. So the difference between the sizes of the two gauges equal to the tolerance on the workpiece. So the difference between the go gauge and the no go gauge. So this is equal to the tolerance on the workpiece. Go gauges check the maximum metal limit and no go gauge checks the minimum metal limit or least metal limit. Next we will discuss the go gauge and no go gauge for the hole and shaft. So we know that go gauge is using the check the maximum metal limit condition and no go gauge is used for the minimum or least metal condition. So in the case of the hole, maximum metal limit is when the hole size is as small as possible. So that is the lower limit of the size. So in the case of the hole, go gauge is corresponding to lower limit of the hole and no go gauge is corresponding to the higher limit of the hole. So we know that go gauge is using to check the maximum metal limits. So in the hole, maximum metal limit is possible when the hole size is the lower limit. So go gauge for the hole is using for the to check the lower limit of the hole, and we know that no go gauge is used to check the least metal condition. So in the hole, least metal condition is possible upper limit of the hole. So no go gauge for the hole is using for the upper limit of the hole. Similarly, for a shaft, the maximum metal limit is when the shaft is on the high limit of the size. Then in the case of the go gauge corresponds to higher limit of the shaft, and no go gauge is corresponding to the lower limit of the shaft. Next we will discuss the working conditions of the gauges. A part is considered to be good if the go gauge passes through or over the work, and no go gauge fail to pass under the action of its own weight. So which mean, so when we have to considering the part is acceptable mean, if the go gauge is passing through the hole and go gauge is passing over the shaft. Similarly, no go gauge is not pass through the hole and no go gauge is not pass over the shaft. In this condition, the part is acceptable. So this indicates the actual dimension of the part is within the specified tolerance. So if the go gauge is passing through the hole or over the shaft, similarly no go gauge is not passing the hole or not passing over the shaft, then we have to say that when the actual dimension of the part is within the specified tolerance. If both the gauges, go gauge as well as the no go gauge, fail to pass, which means both of the gauges are not passing, it is indicate that the hole is undersize or shaft is the oversize. Similarly, another condition, if both of the gauges, so both go gauge and no go gauges is passes, it means hole is the oversize or the shaft is undersize. So let's see, this is with one example. So let's consider hole basic size is the 100 mm. Let's consider upper limit of the hole is 100.5. Lower limit of the hole is 99.5 mm. So limits of the hole is given. Then hole should be manufactured within the limits of the 99.5 to 100.5. Then we have to say that when the hole is acceptable range. So we know that when the lower limit of the hole is the maximum metal condition and upper limit of the hole is the lower limit of the condition. So go gauge is using for the lower limit of the hole size and no go gauge is using for the upper limit of the hole size. Let's consider. So if the go gauge is passing through the hole means, so here go gauge size is the lower limit of the hole, which is the 99.5. So if the 99.5, that is the go gauge, is passing through the hole mean hole should be greater than the 99.5 mm. Similarly, no go gauge is not passing through the hole mean hole is less than the 100.5 mm. So here no go gauge size is upper limit of the hole, which is the 100.5. So if the 100.5 gauge is not passing the hole, what is the meaning of this one? Hole should be less than the 100.5 mm. So condition is here. So go gauge is should be passed through the hole, and no go gauge is not passing through the hole. Then you have to say that when the hole is within the specified limits. So this is the discussion of the gauges, and thank you.